Today we're in Chicago sitting with Martin Musial, owner of AMS Performance. Stepping into their expansive facility, I was blown away by its size and amount of machinery, which perfectly explains why they're always at the forefront of automotive innovation. Since 2001, AMS has led motorsports innovation, pioneering bolt-in intercoolers and turbo advancements, and setting records across the Evo, GT-R, and V10 platforms. From drag racing to time attack and rally, AMS continues to redefine limits in motorsports. Now, with the world's quickest Lamborghini Huracan breaking into the sixes, we're here to uncover the magic behind AMS's pursuit of automotive perfection. But before we dive in, this episode is sponsored by RACEMOTIVE. Bring your car from the streets to the track at RACEMOTIVE racing events in 2024. From Pocono Raceway, Maryland International Raceway, New Jersey Motorsports Park, and new this year, Maple Grove Raceway, RACEMOTIVE brings you top-tier roll racing events. Their Olympic-style grading system ensures precise measurements for fair competition. From the high-friction NASCAR surface at Pocono to fully prepped drag strips, every race promises excitement and fairness. So bring yourself and your car and use Street Alpha Pod for 10% off all tickets, whether you spectate or race at racemotive.com. Don't miss your chance to race with the best. Welcome back to another episode of the Street Alpha Podcast. I am your host, Tukes, and today we are in Chicago. Today we are at AMS Performance, and we are with the legend, Martin himself. We have a ton of cars. We also have a shop that is full of a lot of machinery, equipment. A lot of R&D, a lot of development has happened in the past to be able to have some of the fastest cars in the past, what, I would say 20 years now? Yeah, 20 years. So there's a lot of history here, from Evos, GT-Rs, now to Lambos, even Infinities. So let's give a round of applause for Martin. I'm super excited for this interview. This is a big interview for me, especially knowing the history behind the brand as well. And it's pretty similar, Street Alpha, Alpha. So there's a lot to talk about, a lot of history, like I said. I definitely want to dive into a lot of the Evo stuff. You guys have had plenty of records. You were the first to get into a lot of the records with a lot of platforms, GT-R, Evo as well. So we could definitely chime in on that stuff and talk about that. What's your plans for the Lambo? Because I know that's like one of the most current records you've broken, right? Having the fastest. So what are your plans for that?
So we're the first in the sixes in the quarter mile with the V10 platform. So it's the Lambo and the Audi R8. I mean, the current plan is just really pushing everything to limit on our end, and then you find out what breaks, what's the weak link, what starts wearing out, then you can kind of trickle it down to the customer as far as developing product, be it drivetrain, engine components, electronics, turbo kit, whatever it is, and kind of like, keep refining it. So as crazy as it sounds, like try to make a good, reliable experience for someone who wants 2,000 to 2,500 real horsepower. There's obviously risks that are involved with making that much power, but that's why we're pushing this stuff to see what we can do and make it reliable.
Right. What made you guys want to get into Lambos though? Because you guys had a background in Evos. So how did you work your way up to a car like this?
Well, traditionally we always worked on turbocharged cars that are they've been all-wheel drive, right? So with the DSMs, the Evos, then the GT-Rs, Infinities, typically we chose like one platform that we really want to get deep into, right? And by deep, I mean we're not like just making some bolt-on parts and calling it a day. We're like going stupid on it, which is a good term to use because sometimes it is stupid. You figure out what breaks and make that part, right? But sometimes they get to a point of diminishing returns where you're making stuff for like 10 customers, but you want to push in a platform and seeing what you can do with it. So when the V10 was kind of like, okay, we did the GT-R, we did this stuff. What's the next kind of big thing that, we can take a deep dive into and make a lot of stuff for? Obviously we saw like Underground doing these, have been doing it for a while. So we started playing with them. It was obviously not turbocharged from the factory, which is kind of, outside of normal scope of what we do, but, it was still all-wheel drive, had great potential. That's something we look for too, is what platform has a lot of potential. It doesn't have to be exotic. It could be regular car, but it's got potential. We're interested in it. So that's kind of what made us get into it. And I'd say also I like a challenge, right? Which is, I don't know if it's stupid or not, but sometimes I like doing things that are difficult.
Right.
But at the same time, if you do something that's difficult, it's harder for other people to replicate, right? So that was, you know, a big challenge. Is how do you make these things work? How do you tune the stock ECU? How do you make a turbo kit? How do you make all this stuff live? The drivetrain, I mean, all this stuff. So that was kind of like, it was a challenge, and, you know, how far down the rabbit hole does this platform go? And
yeah.
Obviously, you know, we started doing is play around with these a long time ago, actually, but, you know, now we see today how everyone's doing them.
Right. They make these in rear-wheel drive, right?
Some of them, yeah, like the STO, some of the Audi R8s are rear-wheel drive, and then very few, but then some of the Lambos also are rear-wheel drive, but they're almost all all-wheel drive.
Because a lot of the fastest cars are rear-wheel drive, technically, right?
No, I think the fastest cars are all-wheel drive.
All-wheel drive?
Yeah. I'd say, depending where on the street, all-wheel drive, because obviously you're traction limited.
Right.
At the drag strip, like this thing, we converted to rear-wheel drive because, you know, we go pretty ham on censoring the car up. We got like ride height sensors. We're looking at, you know, all this stuff, and that was a big thing with like this Lambo was wheelie control, right? How do you put as much power down without it doing wheelies? Because we got some, it was great for marketing, right?
Yeah. Because
you got a shot of this Lambo going on the track, you know, 45-degree angle.
I've seen those photos, yeah.
Yeah, so that was pretty nuts, but it's not fast, obviously. So, you know, there's a whole lot of hardware thought, you know, a strategy that went into controlling that wheelie, and, you know, we went up to a point where we're looking at the ride height and what the front wheels are doing, and they're literally skipping down the track. They're literally just barely,
wow.
We're keeping the front wheels on the ground enough to give steering input, and not even a lot. We're not, because they weren't talking like it was a ton. It was enough to kind of keep, you know, you can put steering effort into it, and it would keep the car going straight. But I mean, a lot of it was like, we're not really using the front tires for traction, so let's take advantage. Let's take all that weight out and put it where we need it, for example.
Right.
To be able to keep the front end down more. So that's kind of, you know, why we went to rear-wheel drive in the car, because it wasn't advantageous. That's on the track though, right? With the 15-inch bias ply slick, you know, great track prep, and obviously, you know, a really well thought out traction control system with the proper hardware to support it.
Right.
So, yeah.
So what other challenges were you facing with this platform, aside from just switching it to or converting to a rear-wheel drive?
Oh my God, how much time do we have?
Well, some of the bigger challenges, especially with a platform like this, yeah.
In the beginning, electronics. I mean,
okay,
you know, how do you keep everything happy, electronics wise? I mean, Motec eventually came out with the plug and play ECU, which made life a lot easier.
Okay.
You know, but just that, how do you keep everything happy? I remember we built a car for a Netflix show, and this is before Motec had a plug and play. We're just still tuning the stock ECU. We're still learning a lot about that. We weren't able to, I think, tune the stock, or we weren't able to tune the TCU, the transmission computer, at that time. So, you know, we gutted this car, put a cage in it, and this thing has so many modules. I mean, it is crazy how many modules it has and the amount of wiring in this car.
Right. And
literally, you piss one thing off, and it won't go into launch control. One thing, like you unplug the CD changer, and it's like, not going to launch control. It's something stupid stuff like that. So that was a huge challenge. I mean, we spent months chasing down, you know, wiring issues, or just like how to get all this stuff to work. That was a huge challenge. Again, this was before Motec came out. Transmission tuning, that was a big kind of unknown in this platform. There was some, you know, finally we were able to read and write to the factory TCU.
Okay.
But then there's some, like, you know, no one had the secret sauce or the recipe or the instructions of, hey, there's 30,000 maps in there. They're not identified. Some of them are single value can adjust. Some are 2D maps. Some are 3D maps. And you had no idea what you're doing, or no one had an idea. But somehow, somewhere in, I don't know, Europe, someone made a file and everyone just used that. I remember us getting it and trying it, and I think they found every table or value that had the word pressure in it and just turned it up, because the shifts were slamming the shift fork. So, like, you know, there's pressure control, the shift fork gets moved by hydraulic pressure.
Yeah.
So I think it was like slamming the gear and then trying to push the shift fork past the gear. You can feel it kind of, it was wild, and like it was going to break stuff big time. So I think the big challenge there was once we finally were able to get information to even know what to change in there. And then, the tuners, Jake and Miles, just spending a huge amount of time, just playing, right? Testing, playing, logging, seeing what it does. How do we change, shift pressures? How do you get the clutch pressure up so it holds, but also so it doesn't engage harsh on takeoff? Then, so that was, I don't know how many countless hours. I don't want to know because I'm sure we'd not make money on that, but and they then had to figure out how do you control launch control, right? On this thing, like when the clutch engages, how do you maybe slip the clutch more? Where do you engage the clutch? That was a huge undertaking, figuring that out. But now, a lot of the fastest cars use our TCU tuning. We do a lot of TCU tuning for other shops because, again, we put the effort and time into figuring all this stuff out, and it's complex stuff. And
So a lot of your history is being the first to innovate and create products and so on. Earlier on with the Evo, right, when you were developing, I guess, manifolds, right? What were some of the challenges you faced there with designing some of the manifolds, and especially not having a shop like this?
Yeah. Back then, there was a lot of challenges. Back then, wide bands were not as easy to come by and cheap as they are now. This electronics in general were a little more archaic. You didn't have I remember even us designing our intake manifold. The software that we used to do it, then to find the suppliers. You're talking about the intake manifold, right? Yeah. That was, man, it was a great manifold, and I kind of I worked with this guy Drew that worked for us. He was a fabricator, then he was designed stuff in CAD, and him and I kind of collaborated, and I had this, I had the vision, his wild ideas, and he made it look good in CAD. And these offset trumpet bell horns and this thing, and it looked great on paper, right? Or on computer, I should say, not on paper. It looked awesome. This thing's gonna work great. Looks awesome. And then you go to manufacturers to try to make it, and they all look at it just scratching it, how the hell are we gonna make this thing? We're gonna cast this thing, and so that was a huge challenge. And it was, over the years learning. What you design, for example, and what a manufacturer can make are two vastly different things. So, today, comparing now to back then, we go into a project, we know, hey, design it this way so someone can make it. Because, you design it cool, but if they can't make it, or if the scrap rates, I think the scrap rate initially on that intake manifold was, it was massive, 50%. Basically, they didn't want to make it. I think the company that made it, the casting house that they're in Michigan, I think they got some award for the tooling because it's so complex.
Oh, wow. And
it's part of the reason they made it was a challenge for them, right?
Yeah.
Normally, because in our industry, we'd call suppliers and we go, can you quote us 200 of these? 200,000, no problem. No, 200. Hello? They just hang the phone up on you, right? So the trick was finding someone who's willing to do low quantity stuff and do difficult work. So that was a lot of the challenges back then. And I had no idea what I was doing business wise. We want to make cool stuff. We weren't thinking of our bill of material costs and what engineering time went into it, and all of the boxing of it and the shipping and all the other. We just want to make cool stuff, right? So we had no concept of what that looked like on the business end of it.
But why an intake manifold for the Evo? Was that something that you felt like was a restriction on the platform?
Once you get above a certain power level. So everything affects any changes you make to an engine can affect the volumetric efficiency of it, right? So from intake system, intake manifold, especially depending on what you do there, as far as the runner lengths, the runner shape, plenum volume, that all plays a big part in it. But also all that stuff goes together. If you just put a big cam in the engine, but you don't change anything else, you can have a loss. I think it'd be a dog down low and mid range, and maybe pick up a little power up top. Yeah. So you really have to kind of build a package out, with maybe an intake manifold, a camshaft, properly sized turbocharger, everything else around that to kind of, build out what an engine should be. You can't just, pick and choose the biggest camshaft because it's, it's the biggest cam. Sometimes you actually go slower that way. So
right.
intake manifold, I think once we made a turbo kit for the Evo, we're able to make some pretty good power on it, and the stock intake manifold became a restriction. So I mean, we played a lot. We played around a lot with intake manifold. I remember we designed some stuff, and we actually had it. Oh man, this is like the infancy of 3D prototyping. We had and this is like, I mean, if you wanted something 3D printed, you had to go to a big company. You had these giant printers that would print stuff, and we actually got one made, wrapped it in like fiberglass. I remember to make it stronger and bolt it on. We're like, we're only going to test at 7 pounds of boost, right?
Right.
So we test the stock manifold at 7 pounds of boost with our big turbo on it. Then we bolt this thing on. And we literally had like ratchet straps pulling it to the engine in case, it was going to blow up and just shoot off the back of the firewall, right? And, we had some sensors on there and some of the things we learned even back then, like when you're testing product like that, where you put the manifold pressure sensor makes a difference. And, we learned that, I'd say the hard way because we got interesting results. And like I started moving stuff around. I'm like, oh, if you put the map sensor directly across from an intake port, you get a different reading if you put it in between or if you put it in the end. So then you have to mimic where the factory put. So it's, and then I saw people testing manifolds, down the road, and they get a result and like, where'd you put your map sensor when you were testing? That makes a difference. So, again, testing on the dyno with all the sensors and then running that manifold and revisions of it, we saw, hey, this thing lost a little bit down low, but we picked up a lot up top.
Right.
So that's kind of, that's why we built that manifold, because, at a certain point we did the, turbo kit, intercooler, all the bolt, camshafts. Yeah. The intake manifold was the restriction. It was the next thing you had to change.
So I was telling Ty earlier that when I was younger, about when I first got into cars, I always saw the Evos with the the iconic AMS front mount logo. So even my mom, she's not even into cars, and she remembered your company name just by the AMS. So there are some parts back then that I do remember that kind of made me always curious about, like, who is AMS? Like, what is this company? So that's when I started looking more into Evos. Yeah. And then you guys also eventually branched out into other platforms as well, right? Yeah. So with the intercoolers, back then, was there any type of specific design or anything that was unique about your intercoolers with the Evo back then? Outside of just like the branding on the front?
Yeah, I mean, we again, with everything we did, we didn't just kind of pick something arbitrarily, right? We'd go, why is this part going to work better? How can we make it work better? So, initially we're like looking at intercooler cores, right? And there's a lot of companies back then. God, it was like Spearco was one. Spearco. Bell Racing intercoolers. I think Garrett was making stuff back then.
Were they making cores back
then? I don't know if they were making cores back then.
This is like what, 08, 07?
Yeah. This is 05, I think 06. Maybe that's when it started. But yeah, then that time period, 08. So we'd start testing. We'd buy different intercooler cores, start testing them, and like, oh shit, there's a difference. There's a difference between, even though the same size intercooler core. Yeah. This one actually, you got a 20-degree better temperature drop across the core. I think back then, a lot of shops just buy a core, slap it on, and sell it, right? Where we go, okay, before we sell it, does it work? So we put a thermocouple, and God, even thermocouples, people use like a GM intake air temperature sensor, right? That's what a lot of, like, that's now, but now OEM cars are much more refined. The Bosch stuff's really good, but back in the day they used a GM intake air temp sensor, and it was notoriously slow to respond. Like, it was very slow to respond. So, during a 8-second dyno pull, the response time of the sensor is so slow, you're not seeing what's actually happening, right? Okay. So sometimes you see like people come out there and say, my intercooler is so good, it cools below ambient. And like, well, no, it doesn't. Like, you start it's like the sensor's heat soaked, it's super slow to respond. And as you do your pull, the temperatures drop. That's not what's really happening. So, right. I mean, we've got like these crazy thin wire thermocouples. It literally looks like a human hair. And you can sit there and like blow on it, and the temperature go up and down that fast. Oh, wow. So that's what you need to test some stuff. So we put those thermocouples in the inlet of the end tank and the outlet, right? Yeah. And you can really see what's happening, right? They are coming out of a turbocharger. If you had a slow response like a regular intake air temp sensor, you might go, oh, it got up to 207 degrees. When in reality, it got up to 350, right? Because if it pulls like maybe 6, 7 seconds, it happens so fast, that thing shoots way up. So you're seeing turbo outlet temperatures 350, degrees for example, and you want to see what's happening on the other side. And, capturing a 20, 30 degree temperature delta with that kind of sensor is easy. But if you have a low resolution or slow response sensor, you're never going to see that.
Right.
But 30 degree colder intake air temp into an engine makes a huge difference. So, that's kind of where we came with that. Like, we chose cores that work the best, tested them, make sure, we test pressure drop across the core, all that kind of stuff. And then, that's how we learned,
You have an engineering background, right?
I do, a mechanical engineering degree. Yeah.
Okay. I feel like a lot of people who get into this kind of business, they figure out a way to make their car fast, but there's levels to it. So what are some of the tips that you can give to people who are starting a shop that maybe they don't have that background you have? Is there a different thought process that you go into when you're creating products?
Yeah, I'd say so. I mean, I think it was a blessing and a curse because, my engineering background and mindset, put us on a path of developing some really good products.
Yeah.
But also it put us on a path of going too far with some things, like over engineering, right?
Okay.
Like never satisfied. Oh, it's not good. We get a little more, and you're chasing the last few percent when, like, I could have stopped, weeks ago. It would have been good. But no, for someone getting into new, and again, do you need an engineering degree? Absolutely not. What you need to be is curious, right? You need to ask questions. Don't make assumptions, and that's like the whole thing with the internet, right? Everyone's an expert out there. But really, if you're getting into stuff, if you're a customer or if you're a shop owner and trying to develop parts or products, it's ask questions, be aware that you don't know everything, learn. There's a lot of resources out there. There's, and I don't mean going just, to the internet, listening to the first good person. There's a lot of books. There's a lot of, YouTube videos, a whole bunch of resources. But being curious, taking a deep dive to really try to learn about stuff, look behind the fluff of some stuff. And that's what it takes, right?
Yeah.
And you might get lucky. I mean, if you don't do your research, and you might pick something, either a supplier for intercooler core or whatever it is, you might get lucky. But that's the rarity, not the norm.
Right.
If we learn, we have to do your due diligence to figure stuff out. If you want to call your product the best or really good, you got to put the work in to figure it out.
Right.
Yeah.
Right. So you mentioned intercooler core.
Yeah.
Don't want to skip over that. No, there are a lot of people who look over that, like they say, oh, you can just throw anything in there. There's a couple brands out there. There's certain cores that you can just throw. It's just the intercooler. But how important is that? Is a core, or at least the size of it, in relation to how much power you're making?
So if you're talking like a air-to-air intercooler, there's obviously air-to-air intercoolers. Then you have air-to-water intercoolers. And then you have the for air-to-water systems, you have the heat exchanger, which is basically like a radiator, right, to cool the water down that's in the air-to-water intercooler. So they're all very different. They're all very different. Like it really depends on the application, right? And and if you have the space, right, and if the space dictates and lets you put a front mount there, intercooler, hey, the turbo's right here, this is right here, I got plenty of space in my bumper and I have a big opening. Keep it simple. Do an air-to-air.
Okay.
And as long as you can size it appropriately, right? And anytime you're doing intercoolers, if you can, if you can bring your charge air temperature, which is the air coming out of your turbocharger or supercharger, if you can bring it down as close to ambient temperature, like outside temperature, it's a win. So you just got to size stuff appropriately. Sometimes, I mean, it's easier, it's better to size it a little too big than too small as far as intercoolers go.
Okay.
But that's kind of the testing we do when we develop a core. It's like, hey, what we're looking at for power, we kind of just based on experience, we know what works. We'll choose a core, but like you said, size is not the only thing.
Right.
I mean, size is one factor that goes into it, and I think people don't realize that because they'll see cores that are, it's the same size, but this is half the cost. It's the same thing. Right. It's not. There's a lot more goes into it. It's it's what's the fin density, what's the fin type. There's different types of fins. There's offset. There's straight fins. There's louvered. Then like I said, the fin density, the row height. How many ambient air fins do you have compared to the tubes that carry the charge air? There's a whole lot that goes into it. you know, a lot more than size. And I'd say size is one factor of it, but then the rest of the intercooler, like I said, all those factors come into play that really dictate how well it works and how much heat it rejects and how much it cools down the charge air.
Now, does having the intercooler further away from the turbo cool it down more? Or does that, like, because I know people say that it's probably better. I know people do like V-mount setups.
Yeah.
And from what I've heard, people say that you get better spool times if your intercooler is closer to the turbo and you have less piping. Is that true, or?
You know, depends what you're doing, right?
Okay.
If you're maybe a drift car where you need a really fast throttle response,
right?
And you got to, I mean, there might be some, but at play there, but I've never seen it, you know, any really appreciable difference. Like if I shorten the piping by 3 feet, man, I could really feel a difference. Not really. I mean, it's given the volume of everything and how much actually, you know, 3 feet of piping, how much volume it takes up, how much it adds, it's not a massive, you know, difference. I mean, it'd be an interesting test to do. I mean, you know, we built actually a turbo test car, that Evo.
Yeah.
You know, that was one of the tests I want to do. I want to literally make an intercooler, like ridiculously long piping, like put it like, you know, 10 feet away, the intercooler, and run all this piping is one test I wanted to do. But I'd be surprised how much difference it makes. I mean, we did some boost leak tests in the past. Like people think, oh my God, there's a tiny leak, there's bubbles coming out. It's like, that's so insignificant. And I watched like, who had it? It's a shop in Florida that did a test on their engine dyno where they literally have a
clear end tanks.
No, they actually start drilling holes in intercooler piping. They put an eighth inch hole. They drill an 1/8 inch hole in the piping, right? And it makes no difference on power. Zero. An 1/8 inch hole, right, in the piping. I think once they started getting over a 1/4 inch hole, they started the power, like the turbos had to work harder. But you'd be surprised. I mean, small leaks, if you're really chasing the last 5 horsepower, maybe. But like small leaks, if it's a tiny leak, it really doesn't make a difference. No, I mean, given how much air that thing's flowing, I mean, you know, if you're making 500 horsepower, it's 50 pounds of air per minute roughly that you're flowing. A tiny leak is insignificant in that case. So piping what length? I don't know. Unless you're, you know, extremely long, or if like in drifting where you need a very fast throttle response, that's maybe where it might make a difference.
Interesting.
Yeah.
So is air to air better than air to water for intercoolers?
It depends. I mean, if you're drag racing, I'd go with air to water because you can put an ice tank in it, right? So a lot of the GT-Rs and the V10s that we drag race, I mean, there's a dedicated ice tank. You know, it's insulated. We got a big air to water intercooler core. You know, you throw a ton of ice in there, and it's literally circulating 32 degree water through there. You know, through the intercooler. So, you know, you look at your intake. Your intake air temps when you get on launch control, and it can be like 90 degrees and humid, and here you are at like 45 degrees or something stupid like that, right? Yeah. So their air gets way denser when it cools down like that. So, you know, it depends. If you're doing that, sure, it adds a lot of complexity, does add weight, but man, you can cool the air down a lot. But for a street car, it all depends on packaging. You know, a lot of the new OEMs now are doing air to water just because of packaging. You know, it can make an air to water core can be much smaller size wise. Like for the equivalent, like how much heat it has to pull out, water's way more efficient than air. So you can have a much smaller core, and the core design is way different versus an air to air. So, you know, they might not have the front opening size for the big air to air. So they'll do air to water, then they put a heat exchanger up there to cool that water down. So it's a lot of it comes down to packaging. Constraints, but you know, air to water intercoolers work really well.
Do you think that a lot of the companies now are trying to cut down on costs, and you think that's probably one of the reasons why they're doing a lot of air to water setups, or does it have anything to do with
air to water or air
to water? Like on the BMW stuff.
Yeah, I'd say if anything, I mean, air to water, and the BMW, it's maybe I think so, because they integrate the intercooler into the manifold, right? So it's all one piece. You know, cost wise, I mean, I don't think they have the room up front for air to air, or even for the piping capacitor. That's all. new cars, I remember like on making parts for the Evos, you had so much room. You open engine bay, you have just tons of room, right? And like the BMW or any of the newer cars, it's like everything's smashed in place. There's covers, you know, they're taking advantage of every single space they have.
Yeah.
So it's challenging trying to make a part better than the OEM because you don't have a lot of room. Sometimes you got to find the room, or you got to move stuff out of the way. Okay, well, this harness is here and this is here. Now we got to make a bracket to move the harness away by an inch or half an inch or whatever, or, you know, move this coolant line that runs through our area. We want to make like in the BMW case, we want to be different than the other competitors out there. So we made a much larger air to water intercooler, but it got in the way of some stuff. So we had to, you know, our kit will include some lines that replace factory lines that you know, the other manufacturers just kind of left that line there and use that as a space constraint. Right. Where we go, hey, we could remake that line, make it bolt in, and now we can make a much bigger intercooler. So it's you know, a lot of it's to do with the space you got to work with.
The space, yeah. I actually I took the motor out of the Supra and put a RB26 in it. Yeah. And there's so much more space. Yeah. So it's crazy how much, like, how simple it is, like going back to the older style cast motors. Yeah. And with these in direct injection and just like the wiring everywhere, it's just like it looks so messy. Yeah. But there is a ton of space in there for you to, you know, swap out other motors in it and transmissions as well.
But I mean, things got a lot harder. I mean, if I can travel back in time and know what I know now back then, man, that'd be awesome, right? But I mean, back then, as I was like, you know, dumb business wise, still figuring out how to make parts, you know, efficiently, and make money on it. You know, but then the cars were way easier to work on, way easier than now. So that's, you know, it's definitely getting harder. It's getting harder.
So back then, the famous Evo, which I'm sure a lot of people would love to hear about, right? That car broke a lot of records, and it also had, I believe it was like the highest horsepower car at some of the events you went to. Yeah, yeah. It's some it was like a dyno. Like a Castrol event you guys did?
Oh yeah, we did. God, back when magazines were around, we did a lot. We did a lot of stuff. You know, that was the Evo 8. So we built a drag car out of it.
Well, it was a multi-use. It was like multi-purpose, right?
It was a drag car, and then we converted to time attack, which is insane. Why would we think about it now? Like, what the hell are we doing? But yeah, and then eventually it became more of a dedicated time attack car. But we transitioned from one to the other, which I don't know what the hell we're thinking. Yeah. But yeah, I mean, that thing was at its peak. I mean, over 1,000 wheel horsepower. You know, we go to Dyno competitions. You know.
Do you remember the setup on that? Like what you were running at the time? Like fuel pump wise, you know, all that stuff, because this is so long ago.
This is so long ago. It's talking, God.
Turbo, maybe. I don't even know, because turbos weren't even.
Was it?
The technology wasn't the same.
Yeah, no. What turbo? We're running a precision turbo, I think, back then. Okay. I think it was a precision turbo. I think we're air to air. I think we stuck air to air because we had to do the time attack stuff for a while. I think we eventually moved to air to water, but. Yeah, I mean, the setup. I mean, the intake manifold fuel system. I mean, we're running back then. C16, I think we're running back then. You know, AM EMS on that thing. We're running. But that was a wild card. It was stick shift, and you know, you had a. You know, I think back then we worked with Exity a lot. And they had a triple metallic clutch, or carbon clutch, which the carbon clutch you had to first heat it up. So you had, like, before you went for the run, you had to slip it, like literally just like try to slip it and put a ton of heat into it, because you know, coefficient of friction gets higher with those carbon components. So then they would grab. If you did a cold pull, it would slip. So and then, you know, as it gets hotter, it grabs harder. So like modulating that thing forget about it. It was like. You know, and it was Eric Jones drove that car, and he was a wild man. But yeah, you have to launch a car and row through the gears, and we held that record, the quarter-mile record, for a long time. Long time. Yeah, with that thing. So that was fun. It was fun. It was stupid, but it was fun.
So, what made you even want to get that car into time attack? Like, was that something that you just wanted to be like the best in, or the first to kind of you know, get into with the Evo? I
mean, personally, I love road racing. Like, to me, road racing versus drag racing. Drag racing is not to say there's no driver skill. There is driver skill, absolutely. Right. But it's a lot of it is, you know, technical. The equipment, it's got its own challenges, and it's obviously a short run. So the driver's still very much a big component of it. But with road racing, it's man and machine both equal. I mean, you got to have, it doesn't matter how much power the car, how well it's set up, you don't have a good driver, you forget it. Like, you know, I did some autocross back in the day. I did some road racing wheel to wheel, actually. I drove like an Evo 10 in SCCA, called T2 back then, wheel to wheel. And, you know, you're on the track for, you know, in the sprint races, 20 minutes. In the longer races, 40 minutes. I did some endurance racing not too long ago in Champ Car Series too. But
right.
I mean, to me, it's you know, you're pushing the limit. And I guess it's the same thing. You're pushing the limit, like with the drag racing. You're trying to find the most. And with road racing, you're pushing the limit of the car, of yourself. How can I get to 99.9% without going over and crashing, you know, or hurting the car. And again, I think what I liked about road racing is when you're running a car, you're really testing it like hard. I mean, you know, 20-minute session on a track you can't replicate that on the street, you know? So for us, it's like, hey, let's test our products on track, you know, a time attack session, road racing. If they can live through that, it can put up with anything else our customers do. Yeah. Yeah. So
with the time attack, right? I kind of look at that as something similar to, I don't want to say similar to drifting, but you have to push the car to the limits for a longer amount of time rather than just ripping it one time down the strip in drag racing, right?
Yeah.
So with the time attack, was there anything that you like kind of implemented into like the drag side of things, or even just horsepower, because you were pushing that car to the limit, and it was longer than just like a 7-second pass?
Yeah, I mean, you know, we built that Evo 8. We time attacked it.
Yeah.
We won. I mean, we won every year we won the championship of that car, and then we had a Evo 10.
Right.
That Evo 10 was just purely a time attack car. Yeah, but I mean, you see different things, right? In drag racing, you're stressing everything to the limit, you know, as far as braking stuff. In time attack road racing, you're putting a lot of different like thermal loads, right? So it could be from your, you know, the cooling system for the, you know, engine cooling system, oil cooling system, cooling down the differentials. You're putting like the exhaust manifold and turbo kit through stresses it normally doesn't see. I mean, that stuff was glowing red hot, right? So it's like you won't see that at the drag strip or the street. You know, if you do a, you know, let's say 8 to 12 second pull in the drag strip, or even someone does a rip on the highway, you're not seeing a, you know, 15-minute session where this thing is, I mean, it literally glowing. You can see through it almost. So, you know, we learned a lot from that. Like, hey, thermal management. When we do a turbo kit, you got to support it correctly. So at that temperature, the metal gets soft and it'll start sagging or deforming, right? So you got to, you know, how do you provide proper support to the turbo kit? Yeah. Heat shielding. Everything's got to be isolated from heat, you know, building air gaps in, you know, protective heat coatings. How do you get airflow? Where do you move airflow, right? Because if there's no airflow, it's going to just sit there, right? So how do you get airflow across it, and where do you move it? So there's a lot that goes into that.
Yeah, I think so. Do you think that kind of helped you guys kind of keep pushing forward and kind of keep breaking records with other platforms later on? Just knowing, like, you know,
what we learned from there? Yeah, absolutely. You know, we did, you know, back when magazines were around, we did a lot of competitions with them, and a lot of them involved, like, it was a dyno contest where we built it was an Evo 8 motor against a whole bunch of other engines and magazines, or, you know, our engines and platforms, and they, you know, did a dyno test on it, and we won that. And then we did a lot of, like, the tests they did were, God, people remember this, was Ultimate Streetcar. There was Ultimate Streetcar Challenge, which is basically the sport compact car chose like the bad, you know, most badass, you know, tuner cars, street cars out there, and you got invited to this competition, and you got a panel of engineers judge the car, how well it's put together, the parts are on it. They do a fuel mileage test, they do a skid pad test, they do a lap time at a track, they do a drag racing test, they do a panic or 60 to 0 test, all this stuff, and everything had to work together in unison. So that was, I mean, again, we learned a lot from that, from doing that stuff, and that carried forward to everything else we do. And, you know, it's kind of sucks that stuff's not around anymore. And if we could be more involved in road racing, I'd love to, but it's so much easier to sell horsepower to a customer or quarter mile time than a lap time, right? If you tell someone, man, we ran, 2 minutes, 15 seconds at Road America with this, like, what does that mean? Oh yeah, we ran 890s in the quarter mile. Everyone can relate to that. So it was a lot easier to sell horsepower to people. That's why we kind of moved more towards drag racing, and building these cars with power.
Now that you mentioned selling horsepower, right? You have this facility now. You have a ton of machines in here, right? I got a shop tour before. It was kind of crazy. I was not expecting it to be this large of a facility. And then when I walked outside when we went to lunch, I'm like, oh, this is the whole building. Like, I think outside it was just like, wait, you guys own this whole lot. So it's pretty cool. Can you talk about some of the machinery in here that you have now that you feel most people, other shops don't have? Because a lot of people say that you guys are one of the only companies that do everything in-house. So are you guys currently still doing that, or you guys working with other companies to build your motors?
So the motors we've always assembled our engines ourselves. That's a whole topic. Engine, machine shops. Unfortunately, I think that's a dying. How's it dying? It's a very old industry, and it's. I don't think a lot of people are pulled into getting into that. Yeah. Because it's really hard. I mean, building engines, and I'll go beyond that. It's developing engines. Because in our case, we're not just you're not just slapping parts together, right? What I mean is, you're not just ordering pistons and rods from this so and so company and bearings and rod bolts and head studs and putting it all together. In our case, we're doing a lot of engine development, meaning, hey, we want this thing to live to X amount of this is our RPM it needs to see. This is the horsepower and torque we expect out of it. Yeah. What else do we have to look at? How else can we push this engine, see where it breaks, and then figure out how to make it, last longer. But, getting back to your point, like, we've worked a lot of different machine shops, and it's always been, jumping from one to the other. Then this one kind of does good for a while, then they have issues, and then, then you learn, like, hey, you get an engine back from a machine shop, and you think it's all good. You put it together, and you ship it overseas to some country, and then all of a sudden, oh yeah, there's an issue here, and you're like, all right, well, we'll pay for shipping back, we'll pay for that, and they get a part, and like, scratch your hand, like, oh my God, like,
how are you gonna explain that to the customer too?
Yeah, and like, and we wound up eating it, but it's like, okay, it wasn't our fault, but it is our fault because ultimately it's our responsibility. Right. You sold an engine, but you working with like a machine shop, or even like, I mean, God, nowadays it's way worse now than it used to be, or maybe just because we know now, like, even parts. Like, honestly, I cannot trust any part I get, aftermarket part, no matter big name brands, everything. I have to verify, double check everything. I mean, because we've been bitten in the ass by, you assume a piston, right? You measure, you put an engine together, you measure what you should measure as an engine builder. Right. You measure a certain distance up the skirt where to tell you, and then you set your piston to wall clearance, and you set your end gaps, all that stuff, and then you run into some issues, like, what's going on here? Then, like, okay, well, now I'm putting a piston on a shadowgraph or profilometer and looking at the shape of the piston, sitting there taking measurement. I mean, spending days, right? Yeah. Basically reverse engineering this piston and going, what the hell did they do here? And then you wind up talking to the manufacturer, like, oh yeah, we screwed that up. Like, I should trust you. I shouldn't, as an engine builder, now I have to do all I'm not going to check every single dimension of your piston, the barrel shape of your piston, all this stuff, which I shouldn't be checking, right? I mean, if you buy tires for your car, you're not going to go, let me check the durometer rating, and let me cut into a tire and see how many plies of steel are they actually using the steel plies. They said that, so it's come down to that where, we're bringing a lot of our, engine machining stuff in-house. We've been doing our own balancing in-house. Bought a brand new balancing machine a while ago. We have, I
was looking at that earlier.
CNC hone, line hone. We now have it's a CNC block machine, so it does all the boring, sleeving, all the operations. But luckily found a great machine shop to work with, and it's in many years I've been doing this. The shop's great, and working with them. So I do some of our stuff right now, but we're bringing everything in house. Eventually, or as we speak, we have most of it in house. So, that's you're in control of your destiny at that point, right? Because when you're not, it's super difficult, and you wind up bearing the brunt of everyone else's work. So
So are you guys actually doing everything in-house like now currently because of the issues that you've had in the past?
Depending on the engine,
okay,
if they require sleeving or not sleeving. We're still having some stuff done, like I said, by a machine shop we vetted and we trust. But some of the stuff we brought fully in-house, but depends on the engine platform. But the end goal, I'd say by the end of this year, is to do everything in-house.
Right.
I will say some stuff doesn't make sense to do in-house. So like the one thing is CNC head porting. That is just like it wouldn't make sense for us to do our own castings, right? If we design a turbo kit, like, we're not going to do our own castings.
Right.
Okay, now you got to build out a casting factory and all that stuff. To me, CNC head porting, to develop it well, to know what you're doing there, and to have the equipment machine, that stuff's got to be running nonstop. To amortize it and make a business out of it, it's got to be running and busy all the time, right? So at that point, you, again, got to find someone who's really good at it, trust them, someone you can work with well together, and build a program together. So that's the one thing, it just doesn't, from a business standpoint, it doesn't make sense,
That's probably why there's certain people that focus on cylinder heads. Okay, that makes sense. So technically, there's no way to even make that happen.
If we did enough engine platforms, like if we did head porting in house, we'd have to do. Like a V10 platform wouldn't support it.
Right.
You'd have to have like probably a porting program, a development program for probably I don't know, at least a dozen different engine platforms where you're churning out, like if you're doing like LS stuff where you're churning out, the machine's busy around the clock just doing LS stuff.
Okay.
Right? That makes sense. But if you got to put a set of V10 heads on once, every few weeks, doesn't make sense, right?
Yeah.
You're not going to be doing a set of V10 heads, 2 a day, every day. It's just not, the volume isn't there. So,
right.
And that comes down to, and I've made bad decisions in the past, like we got to get this equipment because we need to do it here. And then you look at it and use it once in a while and like, oh man, I should have outsourced that to someone who does a good job. And sometimes you're forced into bringing it into in-house because you have no other option.
Right.
That's where we bring stuff in-house where it's like, you can only trust yourself in that situation, right? Or I've had so much trouble outsourcing it that I have to do it, but for like, especially like the products that we make, manufacturing, castings, that's a whole specialized industry and foundry and everything else to do castings. There's, companies that do specialize in carbon layup, even CNC machine parts. If you're trying to churn stuff out, that's a whole business model of CNC machining where, you got to be running ideally multiple shifts around the clock, to keep that profitable. So, you got to be smart and choose what you, outsource, what you do in-house.
Right. So earlier I saw you guys had the 3D printer up there, which is super cool. I've never seen that in any other shop. So basically you guys design whatever, manifold or whatever part you want to design and you throw it on the car and then you take that and you send it out to have somebody else design a cast for it? Or you guys do everything in-house after that?
No. So, typical process for us is, we first evaluate a car, right? So we see what it needs because we've had product ideas. Like one, I'll tell you, it was for I forgot what series Porsche it was, but like we'll make a header, right? Because we look at the manifold, the exhaust manifold that runs from the engine to the turbo. I'm like, this thing looks restrictive. So we spent a ton of time making a nice header, machining a nice billet flange out of the head, nice runners, a billet, collector, and we test it, and we get like. The horsepower gains were, attributed to maybe, error, like a couple horsepower, either that's, and we look at the design, like we did everything right there, but just that wasn't the restriction in the engine, right?
Right.
That wasn't what was holding it back. So we didn't make the part. Even though we sank all that time and effort into making it, we didn't just pump it out and go, plus 20 horsepower, by now. And you'll see that in this industry a lot. You'll see like, I've seen funny. I've seen intakes for the V10s,
right?
Intakes and tunes for V10s NA, right? Non-turbo kit, where the tunes claim plus 30, 40 horsepower, right? Or someone made an intake for these that claimed 20 horsepower. It was like I forgot what it was. I look at it, I'm like, come on, And I remember we tested it. The customer actually, or someone, like by chance, we went to our dyno and like put that in this car. I'm like, can we do it before and after? And it literally made zero difference, right? And even like tuning these things NA, on regular pump gas, dude, I've played with, you know, cam timing. It's like adjustable intake and exhaust cam timing. You phase intake, exhaust timing together, separate. All the tricks you play with, you know, ignition timing. It's already riding the factory knock sensor basically. So you can't go, let me add more timing.
Right.
No, it'll maybe do it one pull, then it retards, and you know the timing pulls it down, and you're actually making less horsepower.
Right.
Air fuel ratio was dead on. We played with that. Nothing to be gained there, and we played as much, you know, as even like injection phasing. Right.
Yeah.
When do you end your injection for the port injection, the PI, and the direct injection, the DI. Right.
Okay.
That makes a difference. When do you inject the fuel? We
Right.
even played with that. They got everything out of this car. You know, Volkswagen engineers or whatever, Lamborghini, you know, the calibrators for Audi, Volkswagen, whatever, Lamborghini, they really extracted everything out of this car. There's not like they left, oh yeah, there's 30 horsepower on the table. I mean, I think with race gas like that, you could get with a little more timing, but other than that, this thing is pretty tapped out, and funny seeing people, 30, 40 horsepower, like show me dynographs before and after, you know, and that's silence, you know.
Yeah.
But it's pretty funny.
So you guys are usually the first to kind of get on board and make a lot of the products, right?
I won't say we're the first, right? Because
usually, not always.
Yeah, but like we won't. Typically, we won't come out with the product first, and I'll tell you why. And it's because it takes time, right, to do it properly. Like, you know, if you're doing I don't know, an intake, right, for the car. It's pretty easy to get a fabricator to go, make me an intake. Make a box, make this, make it happen, just get some silicone couplers, and let's pump it out the door, right? That's kind of easy to do. But then to really look at the factory intake, you know, put it out. We have a flow bench we built in-house, and it's not like a traditional flow bench, which measures CFM and depression. We actually measure mass airflow, because that's ultimately what you're measuring. You're measuring how much, hey, when I change the restriction intake, how does the mass airflow change, and how does the pressure drop change across the whole intake track? So we built our own custom flow bench with a Motec data logger on it.
Okay.
And you know, you assess the factory part. Where's the restriction? Where can we make it better? So, like on the BMW, we've gone through probably, you know, 6 revisions of certain parts. So we make one, we flow the stock piece, we flow ours. There's a good increase, but you know, what we're doing now too is we're getting the competitor stuff, you know, we'll get competitors' products and put it on there, see how we measure up, right? So our goal is to be the best, right? Well, if we want to be the best, we better back it up, right? So, you know, we'll test all the intakes on there. Then we'll retest ours. Where can we make ours better? And you go down the line of, you know, it's not just, oh, make this bigger, this part bigger. Sometimes it's not, with airflow, it's not that easy. But that kind of stuff takes time, right?
Yeah.
Getting something simple out there that looks the part and just get it out there quick and dirty. You know, some companies can do that, but that's not our game. We're trying to be quick on this stuff, but unfortunately, it takes time. You make a revision now that engineers, you know, our engineers got to change it in CAD. We got to put it on a 3D printer, print it out again. We got to assemble it, put the part together, you know, then put it back on a flow bench, make sure it fits in the car. Because again, like we talked about space constraint.
Yeah.
You know, like even as the BMW, there's a lot going on. The intake is, I mean, we're custom molding stuff to fit around stuff.
Right. Yeah.
You know,
so it looks crazy.
Yeah. So they got to reprint it, test fit it, make sure it fits. Hey, does it fit what you just changed? Okay, it fits. Let's put it on a flow bench now and test it and see what it does. And you go through those kind of revision loop until you're like, anyway, remember I talked about chasing the 99%.
Yeah. That
so,
little bit.
You know, we'll do kind of with our flow bench stuff. We'll take the factory part and then I make an ideal part, right? An ideal intake is no restrictions, no tubes, just like a bell horn inlet to the turbo, and we flow that, and that's our 99, that's our 100%, right?
Right.
If we can put X amount of work to get close to that, if we get there, great, but you know, we got to be realistic, right? So that's kind of you got to set what you're chasing too. So
it's random, but somebody in the group chat mentioned the other day, there's no such thing as replica, right? There's only high quality products and low quality products, right? So if I came out with a design, a manifold design, and I was the first to do it, does that mean that I'm the originator of it? If you come out with a better, you know, design of it, like, is it technically a rep if there's always room for improvement?
Yeah, that's a big topic of debate, right? Someone designs something and another part comes out similar looking. I mean, it depends on the product, right? Like, if you've got if the constraints are there, right? Some of the stuff is like, you have no option but to make it this way, right?
Right.
Like you have only this space to do it. How do you take advantage of that space? Well, guess what? No matter who's designing it, they're going to make it look similar, right? But if you have something where, hey, you got a ton of space, a lot of degrees of freedom of designing this product, and someone makes it look exactly like yours, no, that's a problem. You know, when that happened, and that happened to us in the Evo days, it still happens to us, you know, where you'll see someone come out with a literally exact copy of our intercooler. Like our end tank angle, everything's exact replica of it, right? Yeah. And that stuff pisses you off. You really can't do anything about it, you know. All you could do is basically keep innovating and making the next best thing, right? And stay ahead of that, you know, people are copying, and they're going to copy it and get it close, but, you know, in some instances, literally someone copied our V10 turbo kit. Someone copied it, and they're posting it, and everyone's, even people like, that looks awfully familiar, you know, is actually copied overseas.
How did you know it was copied? What's similar?
Just everything from the intercooler design to the whole thing. We have a water tank because we have, you know, heat exchangers up front for the air to water intercoolers. So we designed this unique water tank that bolts to the frame, and it's got a pump that attaches to it. And so it's very unique, right? It's not like, it's like that's the only place you can put it.
Right.
When I saw it's exact copy of ours. I mean, exact, right? And so I'm like, but then they posted dyno graphs, and you can see they got boost creep, they got boost control issues.
I was going to say,
and then I'm like, so look at their webpage, and they copied everything except they didn't get some stuff right. So I'm looking at their wastegate stuff. I'm like, I've been down that road before, and I could tell. I'm like, you got boost control issues. I'm like, you can copy it, but you can't get it exactly right.
Yeah.
You know, so there's stuff like that. You know, I mean, if it's a really simple part, they can copy it, but a lot of times they get it most of the way there.
Yeah. So
it better be really cheap for you to want to buy it, you know?
Right. I could definitely relate to that, because you start looking at things, you're like, oh, like, you know, this person's trying to do exactly what I'm doing over here, but then you start realizing certain things, you're like, oh, okay, I've been there already. I see what you're going through. You're already like, you're a year behind of, you know.
Yeah.
It's that kind of feeling. So it's kind of like you get to know it at first, and then after that you kind of look into it. You're like, something really to worry about.
You can't, because if you keep looking at the past or like looking at it, that'll just slow you down.
Exactly.
Right?
Yep.
Yeah.
100%.
Yeah.
So with the GT-R, right?
Yeah.
You guys were the first. Again, you guys are the first to do everything, huh? So you guys are the first to break into the nines.
I think. Nines,
8s, 7s, and 6s, right? Yep. I think the most, well, for me personally, getting into the 6s was probably the most controversial.
Yeah.
A lot of hype, a lot of energy around that. Now, was that the same? Was that the same for you? Do you think that was like the hardest to get into the 6s, or was it harder to break into like the earlier days with less technology in the 9s?
Oh man, no, that was that was a lot of work. That took a toll, I think, on everyone involved in that. And I'll even say globally, because there's so many teams chasing that 6-second pass. I mean, you know, it was nerve-wracking. Like every week, you know, you'd be here working, doing stuff, you'd race the car, and there's downtime, right? You improve stuff, you break something, you gotta wait 2 weeks till you do something. Like in the meantime, you know, I'm home on the weekend with my family, you're somewhere else, and like you're seeing Facebook, oh crap, this other company's out, they're at the track, they're racing right now. And you're kind of like, you know, sweating bullets. Please don't go 6s. Like, oh shit, you know, like don't beat us first, you know. And then you know, it was it I think Ecanoe, Bahrain, they're chasing this. So it's like you're just, you know, it was this crazy, you know, arms race to try to go 6s. But yeah, that was a lot of work, man. That was a lot of work. I mean, I don't know if we would do that again. I mean, that was not only because, you know, you're doing it with such haste, I'd say, like, made me think now we're a little more methodical about it, and a little more planned out, like, how do we get there? Back then it was like, just do what you got to do. I mean, we'd look at cost, at time, at our own health, probably. You know, we'd go to tracks, and it was just crazy long hours, and we ran that 6-second pass. I mean, that was, you know, there's a whole video we made about that, you know, you watch, and at the end you're like, man, you like live it, you know. And you know, the car initially had an issue, like had a misfire, and that caused one of the, you know, had a misfire that caused one of the exhaust runners to get really hot, and it caught something on fire. Yeah. And the car came in, the pit's smoking, you know, and then we had to basically we had to build an engine, rebuild a wiring harness, rebuild front of the. I mean, it was like, you know, people are zombies working on this thing, you know. And the team, you know, the effort they put in, and the heart they had to get that car back together. And then when it ran, you know, even at the end of that run, like something, like I forget what happened, but it kind of lost a little oomph at the end. Like, like, oh, and then you see the time pop up, and it ran that 6-second pass, and it was like, I mean, it was a huge weight off, you know, our shoulders. But at the same time, it was like an unbelievable moment that, you know, that you were there and it happened.
Yeah. So what were you running on that setup? Like what? Because I don't know if there's any numbers on that. How much boost were you running? Like how much power do you think you were at on the last pass?
God, we're probably back then. We're probably in the 2,500 wheel horsepower range, somewhere there. Yeah. You know, back then we still didn't have a lot of stuff. I mean, we're kind of like, there wasn't a really good head gasket solution. We're still playing with stuff. We're still experimenting, right? And so, you know, head gaskets were a roll of the dice. You know, we're not where we are now with it. We're now like, was it Dave's car? It's a 68 millimeter car that ran on this motor. He's got 22 6-second passes on the motor. You know,
22
like
6-second
22
passes?
6-second passes on a 68 millimeter car or a turbo. You know, so. You know, we got that stuff dialed in really well, but back then it wasn't. You're still experimenting, still learning.
Right.
So, you know, it's about 2,500, you know, horsepower. We did what turbos were on there at that point? There's 76s, I think. I think they're PT 76s. You know, air to water intercoolers. God, we're playing right. We had some, you know, because the head gasket issues. Like, I mean, you know, earlier on, when we're in development of the VR38, right? When we're pushing it, you know, we're breaking it, because that's how you learn, right? You learn, you can reverse engineer stuff, you can make some best guesses, you can improve stuff, but eventually learn by breaking stuff. Right. So, you know, we're splitting blocks, right? Why are we splitting blocks? Well, we saw the blocks in half and look at it, and you know, hey, the VQ engine was a investment casting, right? Or as a die cast, way, I guess, a more consistent casting. The VR38, because I think the production numbers are lower, it's a sand casting. Sand castings, you have inclusions, parting lines, of all this stuff. We found a parting line. You cut the block apart and see, like in the water jacket, there's a parting line, and our head stud's pulling, you know, across that parting line, and now you're splitting. You're getting cracks at certain torque levels. So, how do we get around that? Well, let's move that stress down lower. Let's drill deeper, tap deeper in the block, get custom studs made, and you know, you fix that. Right. Then you go on the next thing, and then, you know, you keep blowing head gaskets, and it winds up being this one chamber is always blowing. Why? Oh, you look, it looks, well, there's like a gap there. Then you cut it apart, and you see, hey, the chamber is, you know, unsupported there, because the OEM never goes, oh, you're gonna make 1,200 foot-pounds of torque with this. Yeah. They don't design it for that, right? So you're pushing all this stuff way beyond what the, you know, design intent was of the part. So then we had to figure out how to, you know, how to get that to live. So we came up with this, like this, we call it a jack screw. You basically drill through the top of the head, and you put this giant kind of set screw that you machine the top of this, or the bottom of the set screw, and then you machine the receiving side of the combustion chamber to preload the combustion chamber, right? And then you fix that issue. And it's like one after the other. You kind of go through the process and fix that. And like that was, you know, that was funny about that is, like, you know, a lot of people, they didn't see that till maybe, you know, we built the engine for someone, sent it out, and then someone took the valve cover and go, what the hell is that? Why is there a set screw in top? And like, and then a lot of people, you know, I would say copied it. I don't know. I mean, it's just something we figured out.
It's inevitable.
Someone sees it and go, that's a good idea. And it was, and good for them. Use it, you know?
Right. But this is after the 6. This is after you already.
That's before the 6s. Getting to that, yeah. So even after the 6s, we still obviously building GT-Rs. People want to race them, and you're still learning. You're still learning what makes the engine live. And we at one point we try to do billet heads, right? Well, the heads, the weak, you know, it's the combustion chamber is flexing. We might get more flow out of it. We sank. Oh my God, I'm guessing $100,000 in developing billet heads. And I remember the first time we dyno tested them. We rented an engine dyno up in Wisconsin, and we put a motor together. Went up there with, you know, and building a motor for engine dyno is different than a car, right? We had to build this whole stand, and we had to build the turbos and everything, like, you know, how it was all placed. And we go up there, and the very first pull, the dyno operators, the place we rented the engine dyno from, they screwed up the water, how they basically run the cooling water to the engine. Yeah. They didn't run cooling water, and ran the full thing with no coolant. The thing melted down. I mean, that was like, I don't know, $50,000 just down the tubes right there.
Well, you witnessed that?
I wasn't there, but but our in-house engine builder was there at that time, and the guy, like, you know, I just heard the news. I'm like, oh God, you know, and It's like just 50 grand down the drain because someone didn't turn the water on.
That's crazy.
Yeah, and their shop's like, well, we'll pay you for that. They're just like, oops, sorry. So there, what goes into figuring out some of the stuff people don't realize, don't see, and they'll think like, why does it cost so much? Well, if they saw the heartache and the time and cost of getting to some of the stuff,
right?
How you have to figure it out. It's not cheap. It really isn't. So, they're figuring out like head gasket solutions. I mean, that was a whole other ordeal. But you get there, you try and test stuff, and we do it on our in-house cars, or we partner with customers. We got a customer, Jordan Martin, who's worked with for a long time.
Mm-hmm.
We got to deal with him. He pushes stuff. We test stuff on his car, and he's been a great ambassador for us as far as that goes. And he also gets the newest best stuff, and he gets we kind of have a good sponsorship deal with him, and it all works out. But you got to learn some way, right? You're not gonna. And it goes, yep, you got it in the first try. I figured it all out. BS. It's yeah.
So with the head gasket issue, right, and all the other issues you had with the studs as well, billet wasn't an option back then.
Billet block?
Yeah, billet blocks.
Yeah, so we explored that a long time ago. That's a whole other fiasco. We explored that a long time ago. We actually worked with a company up in Michigan.
Mm-hmm.
I won't say their name, but they really, really screwed us bad.
Wow.
We brought them an engine.
Okay.
Brought them all the parts, everything, right? And we said, hey, can you make us a billet block, right? And they go, okay, all right. And I wanted to sign an exclusive agreement, right? Because I'm like, if we're gonna give you the concept, we're paying you for it. Mm-hmm. We're supplying all the parts, and we're working together, right? We'll be testing it, and we'll be giving feedback and like that stuff. I want to have an agreement,
exclusivity.
Yeah, exclusivity. And the guy's like, no, we don't want to do that. And they said, no, I should have walked away from it, and I didn't. And we went through so many iterations of that block. We'd get it, wouldn't fit. We'd send it back engineering report. We'd test it, had issues, and it's going, and it was just never ending loop to the point where we're like, we can't. You guys are not delivering us a part that we can use.
Yeah.
And we found out they're selling it backdoor, and they're backdooring it to people, right? And we were like, well, poor souls. They don't know what they're buying, but that really sucked, and it's like it happens in this industry. It really sucks, but
you've been through a lot, man.
Oh, dude, I've aged.
Got some stories.
Oh, there's some. Yeah, I got some crazy stories, but
wow.
Then we brought it closer to home. Found a good machine shop. Who can work back and forth with us.
Yeah.
And we came up with a really good product. But again, that was probably 4 years in the making. 4 years in the making of the billet block. Then it comes out and people are like, it's $19,000. I'm like, yeah, first of all, it's not just 6061. It's a special alloy of aluminum that holds strength at temperature.
Right.
So the alloy itself is, 3x of what 6061 is right off the bat. Mm-hmm. And then all the time it went to developing that to give you a product that works well,
right?
So that's what but that's a whole.
But that's at the highest level, though. Pretty much, if you're getting a billet block, your build is already elite. You have a lot of money into your car already.
Oh yeah, this is for cars making over 2,000 wheel horsepower, 2,000 wheel horsepower plus. But a lot of people, I mean, that's the go-to block right now is our billet block because it works. It works very well.
You're big on running, especially in the Lamborghini.
Yeah,
cast is important, obviously, because you're running it on there. So why wouldn't you just run it on the GT-R?
Because there's limitations there. I mean, at a certain power level, our billet block has it's a skirted design, so the block material goes along the sides of the crank, and you have billet steel main caps, right? Okay. Individual main caps that are bolted from the side and the bottom. Whereas the factory has a girdle, right? It's funny because when we start making some decent torque, and I'll say torque because a lot of people say horsepower rated and how much horsepower would a clutch hold? It's torque. Torque kills stuff, right? Torque was what breaks stuff. RPM is how high you can spin the engine. But at certain torque levels, you take a factory girdle off, and it's a cast. It's it's a half, right? Mm-hmm. So it's cast aluminum, but there's like iron inserts around the main caps.
Okay. They
literally separate from each other. There's like gaps and they kind of pull apart. So everything's flexing so hard. That stuff's separating. So the limitations of factory cast stuff, it moves around, it flexes. You lose integrity as far as bearing clearances, where the where the crank's sitting. You start just losing all that. So it gets knocked around and won't live as long.
Right.
So that's the limitation with the VR38. But again, you're talking 1,400 foot-pounds of torque plus 2,000 horsepower plus, where you really got to look at the billet block, and the engine just lives way longer.
Yeah.
Right. Everything is a lot more stable.
Right.
The main journal of the crank stays in line better. It's not flexing around.
Flexing.
Everything's not moving around as much. Everything's a lot more stable. The cylinder, right? The bore is not distorting. It's not barreling out,
right.
as much. It's a whole bunch of things come into play. But
Can you use some old school methods, like maybe grout filling or maybe block bracing? And I'm saying this is from like an RB26 kind of thing, because that's very common with that platform, is to use block bracing, grout filling. All this.
We did that. We tried that with the 4-cylinder stuff in the back in the day,
or Evos,
like the
too,
Evo stuff.
Yes.
We'd fill it. We'd half fill it, right?
Right.
So you still get some. You'd still get some cooling capacity, but it'd be filled to a certain level where it still provides some structural support to the cylinder bore, right? It was a little more difficult with the VR38. I think we experimented with that a little bit, but there was not much of a water jacket. And then like even doing it, you got to do it on one side, let it sit and set up, then you got to flip it around on the other side.
It's risky.
But just where the weaknesses lie in the engine, it's just the effort, you weren't getting a lot more out of it, right?
Right.
And back in the day too with the VR38, we learned the hard way too. Was it Darton was selling sleeves, right? Where you literally machine out the bore, the aluminum, the cylinder, basically machine out and drop in this MID sleeve. And all of a sudden, great, the cylinder's not distorting, all that stuff, but all of a sudden you're cracking blocks, you're getting all these weird things happening. You pull it apart and the sleeve's sinking, right? No, the block is actually weakened the structure so much, the block is pulling up around the sleeve. So it's like, okay, that's a no-no. These sleeves are no-no. So we developed like dry sleeve, just the liner. So you held the integrity of the aluminum structure of the cylinder bore, just with a thin wall ductile iron liner, which is stronger than the aluminum. So it kind of provided the best of both worlds. So that stuff, I mean, we went fast just on cast blocks with like dropping the liners we developed.
On the cast?
Yeah, on the cast block.
What were the limits? What can you run power-wise, torque-wise? Sorry.
Torque-wise? I mean, that's...
Or power. I guess power-wise is pretty much what people would go to.
Yeah, I mean, we don't do it anymore just because it's easier to go right to a billet block. By the time you have everything into it, we go to a billet block. But I mean, back then, I think we went... I think it was Jordan's car, which was at that point he had like roll up windows on his car still. I think he went 6s on a cast block with the sleeves in it.
That's fast on the cast block.
Oh yeah. People have done it since then too. So it's But again, if you're gonna do that, you've got a much shorter lifespan with the cast block. That's why you want to move to billet block, and it's rebuildable, right? Like you do something stupid on the cast block, you break a rod. I mean, it's done, right? I think it gets blown apart. But we've had rods that go on a cast block and it'll beat up the casting, but it doesn't punch through.
On the billet?
Oh yeah. I remember on the dyno one time we had a dry sump belt come off at the top of a run, right? It came off and there's like no time. You shut it down and the coast down, it seized up, and it was the most terrible noise, just the rods clanking around there. And you're like, oh my God, please stop as soon as possible. And we were able to use that engine again because the block got beat up a little bit inside the bore, but it wasn't like broken through. There's no cracks. It just you just grind it out and it's good to go. So
wow, I always thought that because I don't know, I could have sworn I heard somewhere that like the cast is good. You don't really need to go with the billet block, but I guess it's at certain power levels.
At certain power and torque levels, it's really highly recommended.
Right.
And that's where we're at with the V10. We kind of the V10 is a little different alloy than the VR38. So like when we do development, be it product development or engine development, I mean, we're actually, we'll cut a chunk off the block or the head and send it out for material analysis. Say, what is this material? What's the hardness of it?
Yeah.
What are we playing with, right? And like the V10 stuff, it's actually really strong but kind of brittle. So it does put up pretty well with the power and abuse, but we do have a V10 billet program in development for that.
Wow.
Because we're seeing a need for that, but that's once you're getting into like the 2,500 horsepower range.
And that's where you're at with this car, right?
We're about 3,000.
3,000.
Yeah.
What?
Yeah.
3,000 horsepower.
I think on the dyno we're at 28 something, but then, at the track we're running more boost, so it's probably around 3,000, close to 3,000 wheel. Like,
and on how many pounds of boost? 3,000.
I mean the GT-R, the VR38, the GT-Rs to run big power, like to run 25 to 3,000 horsepower on the GT-R, you got to run like 80, 90 pounds of boost. On these, it's less, obviously. Bigger motor, more displacement. You don't have to run as much pressure ratio on the turbo, but you're still probably in the 50s range.
50s.
Yeah.
And these heads flow pretty well, right?
Yeah, these engines are amazing. I mean, it's a well-developed NA engine.
Yeah.
It's like this, like the K24, any like really efficient Honda engine, which you look at the power band, I'm like, man, I think would love a turbo. As long as the rest of the engine can live,
right?
Because typically turbo engines from the OEM, let's say like the Infiniti, they're not meant to rev out, right?
Yeah.
They're designed from them. Hey, this thing's going to make a lot of torque. Let's build it robust in this RPM window, right? Because to rev it high, now you're getting into like exotic stuff. Like, okay, now you're gonna make the rods light, got to make the pistons light, all this, all this crazy stuff to make that live. So manufacturers kind of, design stuff for intent, and this was again just really good VE, really good power band curve, and when you turbo it, it just loves it.
So speaking on that too, I know back in the day you had some involvement in some KA motors too, right?
No, we didn't do it. No
Nissan stuff.
Yeah. Okay, so we did a turbo kit for the KA24.
Yeah. So you mentioned that because at that time I'm sure it wasn't really the performance option. So what made you want to dive into that?
Well, I think back then we were looking. One of our guys, Ivan, that worked for us, he had a 240, and people were swapping those. Was it SR20 swap? And we're looking at the cost of the SR20 swap and everything else along with it, and the weakness of that motor. We're like, yeah, let's make a turbo kit for the K24. And sorry, when I earlier referenced the K20, I meant what's the Honda? The
K24.
K24. Yeah, that's a really good, high revving. The K24.
I know you said Honda, so I figured,
yeah. The K24 I don't think is high revving, but that was kind of the whole concept. Let's make a turbo kit for this thing that you can keep your stock motor and just bolt this thing on and make some power. I mean, we didn't sell. Again, when we were doing stuff back then, it wasn't as well thought out from a business standpoint, right? Back then it was like, let's do some cool stuff. You know? We can do a turbo kit for that. Let's do it without thinking, wait, how many people are going to do it? What's the cost involved? What's the R&D time going to be to get a kit to market? We didn't take that into account, and we probably again made some stuff in the past that we probably shouldn't have. In the end, like we didn't make any money off it.
Right.
We just put a ton of time into it, but there's maybe some intangibles in there, like maybe they built a reputation, a little more brand awareness of it. I don't know, but we're definitely we learned made a pretty big switch in the business and of how we do things. Just to it's got to be a business still.
Right.
Because, it's no fun for me or for the employees or even for the risk for the customers if you're running a business by the seat of your pants.
Yeah.
You're not knowing where the next paycheck's coming from, where the next bill's going to get paid. That's no fun. That's terrible.
Yeah. So you made that transition, obviously, because you're in this huge facility now, and you started off that way, pretty much just developing parts, and then you kind of said, like, all right, none of this stuff makes sense. We're not really making or seeing too much profit on some of this stuff. So at what point did you kind of decide to say, well, I really need to tighten up on business and kind of focus on that? Because you guys run this like I was saying to you earlier, this is run like a business. Like it's like, you punch in at a certain time, you leave at a certain time. Normally shops, you go in, most shops will, not most shops, but a lot of shops will, go in whenever they want. They show up at 11 o'clock and they start their day.
Yeah.
They leave
Customers
late.
are back by watching.
So it's pretty common, and sometimes they spend a lot of late nights. But how do you keep everything so structured?
So again, in the beginning, that's how it was like. We'd stay, it wasn't like 8 o'clock. Sometimes it'd be 8 o'clock, sometimes it'd be 9 o'clock, depending how late you stayed the night before.
Right.
A lot that would happen. It wasn't like not that everyone clocks out here at 5 o'clock. I mean, we'll stay late, but I want a good work-life balance for people here, right? Because it's not sustainable. So for me, it was I was doing that, and so was everyone else working with me, and it was fine. We were young. love doing this, love going racing. We do, we'd sleep in crappy hotels to race, doing just, stupid stuff. But, eventually I got older, I got married, I had kids, right? And our kids are pretty young, and I'm like, I can't do this. I'm stressed out. Every weekend, it's no like, oh, here's a weekend, let me relax. Every weekend was like patrolling the forums, looking on Facebook, dealing with pissed off customers or a happy customer, or why aren't you returning, I have a question about your product. It's like the stress of that was crazy. I was looking at like, I could literally go get a job as an engineer somewhere and make more money, right? And actually have like 3 to 4 weeks of vacation. Like that was not like back then. If I went on vacation, I dreaded it because I'd go on vacation, I'd be working while I was on vacation, and I'd come back, and I literally had a line out my door of problems to solve for people. I was dreading it. It was terrible. So like, this is no way to live. I can't do this. So, that's when I was like, we didn't know what our costs were on stuff because it's complex. Like, if you're working cars like a service shop or we build cars, you know what you're buying the parts for. You know how much time you have into it, the technician recording it. You have a good idea of your costs. You should have. That's, I'd say, pretty easy, right? But when you're manufacturing parts, where you have some of your products have, 30 parts in them from 15 different vendors who change your price on you sometimes every 3 months, and you don't have good inventory control, and you don't know what your inventory is. You don't have that in some kind of system, for example. You're lost. You have no idea. Are you making money on stuff? How much money do we have in inventory? I don't know. How much does our stuff cost to make? Well, we have kind of an idea, but not really an idea.
Right.
So one great example is that was like, I got to turn this around. I got to run this like a business. And, to me, someone in the past told me to join this group. It's called Vistage, but there's other groups called Vistage. There's called EO, which is an entrepreneurial organization. And I'm like, well, what is this? And like, you should go. So I joined this group, and it's basically, it's other business owners in various industries, and they kind of group you with similar size, meaning number of employees, size of the business. They kind of group you in a similar category. But here I am, meeting once a month with business owners, someone who runs an insurance company, someone who manufactures, I don't know, plastic bags, or someone like who runs in, all sorts of industries, right? And I remember being at that first meeting, I started talking about business, and they talk about some of the stuff there. I'm like, I literally could not sleep that night because I'm like, holy crap, I have so much to work on. I didn't even know. Right. And so me, it was like, I'm gonna get chills, talking about it, because I remember that first experience. I'm like, I literally could not sleep all night. But just learning the business side, right. Is, good financials, it means record keeping, bookkeeping, knowing your inventory, knowing your assets, knowing what you owe, knowing, your cash flow, knowing your expenses, your SG&A, your overhead, what that runs, because you don't realize that, like, oh, this part, the parts cost me $100 to make this. Let me sell it for $150. Oh yeah, what's your building cost, your overhead? Oh, now you got to put it on the shelf in inventory. It's taking up space. That's costing you. It's paying rent on the shelf, right? So there's a lot that goes into it from a business standpoint that really I needed to turn around. It was not sustainable. I was at a point where I'm like, I was literally considering walking away from it, because at some point you're doing it for long enough, it stops becoming a hobby and fun anymore, and it becomes an anchor and a point of stress. You almost despise it, and I did not want it. It was getting there. So yeah. And the big thing, like, that was the family, right? Little kids. I'm like, I want to grow up like knowing my kids. I don't be every weekend be stressed out and I got to go to work. Dad's got to work, or dad's gonna be home after your bedtime. I didn't want that. Right.
Right. Yeah. How do you know what parts to develop and what parts make sense? Because then it's like, how do you cut that off where it's like, all right, I want to do this, but does it make sense to do that? Do you still take those risks? Because you're always going to have a choice to do something, and obviously if you want to make a part, it's going to cost you money. But that risk may involve making that sacrifice to kind of be like, all right, well, we can't afford this, but I believe in it so much,
Yeah. And that's the challenging part in this business, because a lot of people start with no money, right? You get into it with the passion. You don't have, you're like, well, I'll hire a personal assistant. I know, I can't tell you how many people tell me, let's get a personal assistant. I'm like, you know what that costs? And what, like, this is not like a, you know, it's not that kind of business, you know? So you can't right away hire, I mean, even having a good, I wouldn't say a bookkeeper, but having someone, you know, on the financial side, right? Someone who knows the numbers, I'd say almost an accountant on staff is such a huge asset. Or you outsource that, right? So, I mean, what I can say is, like, going into this business, don't let the passion blind you from everything else, right? You have to realize there's a cost. You're going to pay that cost one way or another. The cost might be, you know, 10 years of your life and stress by not paying attention to other stuff. So, you know, there's plenty of resources out there. You know, make sure you got your financials set up well. And that might mean you're doing the books. You have to learn a little about. You got to educate yourself. I didn't know the books, and when I had to turn it around, you know, I think it was one big turnout point was when we got a, you know, our accountant, we, you know, outsourced accounting, told us we owe X amount in taxes. I'm like, we don't have that money in the bank even to pay the taxes. I'm like, why am I working to pay more taxes than the money I even have? It doesn't make sense. So I literally spent, like, you know, our taxes were due. I spent 2 weeks, probably staying up till 3 a.m, poring over our financials, printing everything out from QuickBooks, learning what a balance sheet was, all this stuff was, right? And I finally found an error, you know, and I'm like, son of a, you know, like, this is, and then their reply was, oops, sorry. I'm like, no, I gotta have control. I gotta have someone who knows what they're doing here. So, you know, business is hard. All right. And that's one of the challenges. Like, what you have to know your finances. Right. You got to have good people. You got to know how to manage people. You got to make good product or provide good service. So, you know, I take the time up front to set that up. At least educate yourself about it so you know what to look for. Because when you're in the heat of the moment, just in the grind, at that point, it's kind of hard sometimes to step back and look at that. You gotta, yeah. Or sometimes it takes crazy late nights or finding a resource. Reach for help. I mean, there's help out there. You can join groups like that, like I talked about. You can talk to people, reach out. I mean, I've provided plenty of advice to people, you know, and I even, you know, on Facebook, I talked about, like, the Vistage, and I talked about why I joined Vistage, and I've had a few people, business owners, reach out to me going, holy crap, tell me more about that, you know? And I've had some people join, and it's, you know, it's a lifesaver, you know? Yeah.
I think sometimes your passion will help, like, it'll help you find the help you need also, like, because you cared enough about it to kind of want to find a way to make it work rather than just giving up and quitting. You know?
And this industry is so unique because, you know, it's so passion driven that, you know, you won't, you're not going to have someone who loves insurance so much and they're going to be like, man, I'm going to work till 10 o'clock at night setting up these free insurance deals for these customers so they can talk about my insurance deal with them online, and I get this builds reputation, and I can just do more of that, you know, like, you know, and then, you know, a lot of other businesses, you know, I'd say are maybe, you know, it's more like they look at it from the finance side. Like, hey, I'm interested in insurance, selling insurance, but where's the finance side? Where this industry is so heavily lopsided on pure passion that stuff, it goes to the wayside, that so many businesses go on for way too long in a grind, a hopeless loop. And it's not good for the customers, to get the best service or the best products, or for the people working there, or for the owners, you know? Right. And I'm not perfect. I mean, there's so many ways to improve, and it's a big learning curve. I mean, I've been doing this for 23 years, and I'm still learning stuff. Yeah, you know.
Yeah, you never stop learning. No. Ever with any type of career. Yeah. So with the Infinity, I mean, you guys are starting to develop some products for that right now, right? Again, for the Q60.
Yeah, we've been doing that for a while. Yeah. That's kind of, you know, we built a handful of bolt-on parts. Right. Went kind of deep dive with that. We're the first Q in the 9s, yes, you know. Record for that. Yeah. And then we obviously when the Z came out, we're the first in the, you know, 10s and then 9s, and hold the record for the fastest Z. But we've been doing stuff, you know, for those cars for a while. Right. We're still developing some new stuff. You know, we've just got an engine program built out for it. We made the first Q with 1,000 wheel horsepower. You know.
And this is up more recently. No?
Yeah, this is very pretty recent, a few months ago. So, you know, we looked again. it wasn't just slapping parts together. It's engine development.
Right.
What's holding this thing back? All right. There's people with camshafts out there, but what else? Okay, head work. So that's when I said you work with someone who's good at developing head flow. It's not just make everything bigger. That's not always the answer. It's especially with head work. It's the valve sizing. It's how you cut the valve seats. It's the port shape, port size. It's a whole bunch of things that go into it. So, you know, work with someone good and developed a CNC program unique to us. And, you know, on the dyno, the guys like, the tuner's like, holy crap, man, this is like, these things typically tank. It's 6,000 RPM. They kind of flatten off and start dropping off. Yeah. And this thing kept going. It just kept going and going. So we knew we had something good there. So yeah, we're still developing parts for that car, engine programs. Some other, you know, came out with a fuel system, low side fuel system for that car recently. That because they're notorious for, you know, slosh in the tank, fuel slosh, and then fuel starving. So if you're making any decent amount of power in that, you know, if you're under half a tank or less, you'll get fuel starvation.
I feel like that happens with a lot of platforms, though. Even the Supra, you have to run in a full tank of, especially if you're doing like I think it's like hard right turns, because it's a saddle style fuel tank. So does that have a similar fuel tank setup, or?
Yeah, but just the way the factory basket is and how it siphons fuel, the exact same thing with the V10s. When you design a fuel system for these cars, you know, we've seen people just drop an extra pump in the tank, right? Yeah. That's great if it's on a dyno, but if it's on the street, it doesn't work. I mean, it works, but again, if you're less than half a tank, it fuel starves. Yeah. Okay, hey customer, now you got to be half a tank or more the entire time. That's not a good solution. So again, a lot goes into that, to developing a fuel system, which, you know, not only has, you know, in this case, in the Infinity, we injection molded a basket, which now clips into the factory, you know, fuel sending unit, holds more fuel pumps, but also now has to siphon fuel into itself and do it correctly, right? Right. So that was that project took crazy long time because we had to learn about fuel siphoning and how to do that correctly. Where you can run that thing on the gas light is on and you can still have enough fuel. Right. So there's a fuel siphoning in there. You got to make sure that from the other tank you're drawing as much fuel as possible. Right. To keep that thing full. Right. So, right. You know, there's like I said, you're always learning. And you know, that was kind of my dream was to have to work with an OEM, right? I've always wanted to work with an OEM. That was the ultimate goal. So I remember, what year was this? 17, 16. When one of the people up front goes, "Hey Martin, Infinity's on the phone for you." I'm like, "Infinity, like a dealership?" I'm like, what the heck? I'm like, all right, I guess I'll take it. And I answer the phone, and it was actually someone from Infinity Corporate, and and they reached out like they want to work with us, and I was in like, oh my, holy, like what? What? You know, and part of that was Hiroshi Tamura, you know, who you know is known for the GT-R. Yeah. I met him at Texas 2K. Yeah, super cool guy. Yeah. He's awesome. You know, he came out, and because we're doing stuff with the GT-R, he came out and visited us. He's like, "How are you guys doing this?" And you know, he went to our engineering department and showing them like, "How do you know how to get the correct clearances for?" Like, he was amazed how we did this stuff and made this stuff live. So I think, you know, there's some probably connection there with Infinity, and like they came to us just like, "Hey, you guys engineer your products." You know, our philosophy was like, do it like the OEM, just better, right? Meaning, you know, they obviously have constraints cost-wise, right? Right. That intercooler intake has to cost X amount, right? Exactly, yeah. So in our world, aftermarket world, people are willing to pay, you know, that intercooler might cost them, you know, $80 to make, right? That's what all they can spend, the engineers can spend. In our sense, like, hey, we can spend more. The customer's willing to pay more for more performance. So let's take that stock part, let's make it fit like it belongs there, right? Like the OEM part. Let's make it fit like it belongs there, but also let's make it, you know, perform better. And then I think that was part of the reason they reached out to us, because, you know, they said like, hey, your level of engineering, your level of fit and finish and quality is on par where we want to work with someone like that. So it's been awesome working with them. You know, has its perks, you know, seeing some stuff that, you know, normal people probably don't get to see, you know, and being part of that, it's been pretty awesome. You know,
early on, what was like the setup you had when you first broke the record with the Q60? I
mean, the tuning was a big portion of that. Tuning. So, you know, working with like Ecutech, right? Okay. Working with Ecutech in England, you know, being a technical partner with them, and we have those kind of deals with a few other companies out there, right? some hard part manufacturers even, where we're technical partners, meaning we test their stuff, we provide feedback, we do some development work alongside with them. So that was a big kind of hurdle. Is you know, with Ecutech, they were interested in doing these cars. We provided, you know, files from them. We'd test stuff for them. They'd build us a test file. Hey, see what this does. You know, so that was I think a big advancement, and you know, I think a big role we played in making these cars as mod friendly as they are now, right? Because without the tuning, good tuning, because I'll say there's more to it than just being able to turn the boost up, right? There's safety features. Hey, you build in you know, if the oil pressure gets too low, or if, you know, lambda gets too low, whatever, like there's other things than just, you know, making more power. So when you have a good, you know, tuning solution, which Ecutech does, they're fantastic to work with. When they build out a tuning suite, it's well thought out. And again, we're a big part of helping bring that to the market. So I mean, there was that. I'm trying to think, we had a good intake for the car. So there's some intakes out there that had issues. So we developed a good intake for the car that was CARB approved, worked well, you know, made more power while still being, you know, emissions compliant. So it came out with intercoolers, air to water, you know, new upgraded intercoolers for it, which helped a bunch. And that was hard because they're in a tight space. There's not a lot of room. Yeah. And you know, that's where, you know, I saw someone coming off the air to water intercooler, and they said who they're using for the core supplier, and I knew right away that's not going to work, because the fin density, that type of air to water intercooler from that supplier is not. It needs to be really big for it to work, right? And the space I had would not work. So that was a long path of we had to pay for custom tooling to get the cores made, because hey, this is space we have. Let's get the fin density like this. Let's get our, you know, the fin type, everything packed in this space, and get it as efficient as possible to make a good intercooler that actually makes a difference. Because we've seen parts for Infiniti or other platforms where the replacement part sometimes, or the upgraded part, is worse than the stock. Yeah. Right now, there's in the VR30. So one of the things I talked about, like, you have to check everything. So you know, we'll get as granular, and we learned this kind of the hard way. Fasteners, right? People tend to rag on torque to yield fasteners. So a lot of these new cars have torque to yield, right? Okay. So, you know, in assembly, they have a process. They torque it to a certain level, then they turn the wrench, you know, X amount of degrees, and it puts the bolt into yield, which means it's in a state where it's permanently deformed, but it has a certain clamp load, and that clamp load on the fastener doesn't change with temperature. It kind of stays the same, and it's very repeatable. As we found out, hey, why are they using this? What's the aftermarket doing? And we bought special load cells, which is looks like a big washer that measures how much clamp load, right? Because when you're torquing something, people are like, oh, torque it to 100 foot-pounds. Torque really doesn't mean anything. All torque means is the resistance of the bolt, right? Yeah. So if you take a bolt that the threads are screwed up and it's dry, unlubricated, and torque it to 100 foot-pounds, versus a thread where a stud where the threads are polished because you've used it 10 times, and now use a good lubricant, and you torque it at 100 foot-pounds, that clamp load that's providing squeezing together could be 3 times what the other one is. So we found out that torque to yield bolts, I mean, we're talking within like 2% consistency across, for example, cylinder heads, right? They're torqued down, everything's clamped evenly across the whole cylinder head, right? In this case, we found out the aftermarket hardware was worse than stock. Really? Someone's like, upgraded to this, you know, and like, we're torquing it. First of all, what they recommend to torque to, just regular studs and just using a torque value, it was varying like 10%, 15% across the cylinder. Now you have uneven clamping loads. Right. And it was lower than stock. We're like, okay, so the upgrade is that you're going backwards. So we use stock head bolts in the VR38, in the VR30s, and people are like, why using stock head bolts? Because they work better than the aftermarket. That's crazy. And you don't need them. We've made 1,000 wheel horsepower, and I forget how much torque on factory gasket, factory head bolts. Right. So I watched a video a while ago on studs. They wanted to see what the difference was and what holds better. The strength of each stud. Yeah.
And apparently, when you put the lubricant on it, you can get a higher.
You'll get more clamp load.
More
for
clamp
the same
load.
torque.
Sorry, yes. Clamp load. That's what the word is.
Yeah.
By using the lube that comes like the ARP.
Correct. Yeah,
right.
And depending on what lube you use, if you use engine oil, you use ARP lube, or there's other lubes out there, you get different for the same torque level.
Yeah.
Your torque wrench, beeps or clicks at 100 foot-pounds. You'll get different clamp loads out of that, out of that stud, the nut and stud. It goes deeper than that. It goes so far. We had an issue a long time ago where we were torquing head bolts, head studs to the recommended value from ARP, which they don't know what the requirement is. They didn't buy an engine and do a clamp load test and compare the stock and torque it to this torque because that's what the clamp. They usually set it for like torque it to this level because you'll get max clamp load without getting into what's called yield for that stud. If you go too much, it'll go into yield, which means that stud's basically ruined. It's beyond its limits, right? So. But sometimes that's too much. That we actually were cracking blocks. So we had a rash of we're cracking blocks, and I'm not joking. When this cost us probably in a span of a few months, a couple $100,000. We had to replace engines. Like they're cracking before they even they got put in. They're cracked, right? And that made me go, "What the heck is going on here?" Right? And this is when me and another guy, Lance here, we jumped in and rebuilt the whole engine program from scratch here. Like every step, every process, everything you measure, you spec, you do. We kind of rebuilt that program from ground up because here you give someone, if I give two people a torque wrench and the hardware and go, you torque it to 100 foot-pounds, you torque it to 100 foot-pounds, you'll get different results, right? And in this case, the person who was torquing it, they're putting lube under the washer. You're supposed to, some people say lube only on top of the washer, never under the washer. Some people say, no, lube under the washer. They're putting lube under the washer, and the way they're physically torquing the stuff down to 100 foot-pounds was enough clamp load to crack blocks. So that's when I started scratching my head, and we bought this test equipment. I built a mock-up kind of head and a block, and I started playing around with stuff.
Yeah.
Right? And that's when I was like, oh my God, if you reuse a stud, every time you use it, the clamp load goes up when you torque it because it's polishing the threads, it's providing less resistance. As soon as that washer spins, if you're ever torquing it and that washer spins a little bit, your clamp load just shot through the roof because your torque didn't change. You'll feel it in your torque wrench. The torque wrench turns, but there's no torque, kind of slips a little bit.
Right.
The washer spins, right? The nut's tightening down, torque didn't change, but the clamp load just shot through the roof. So we literally had to come up with techniques, and it's pretty elaborate techniques to do stuff like with the VR30, with the V10, with the GT-R, everything from cylinder head preparation, block deck surface preparation, what that looks like, to an exact procedure and clamp load for all the hardware to make sure, hey, you got the right clamp load so it's even, you're not overstressing everything. It's high enough where you're not overstressing and deforming stuff, but it's going to hold the cylinder pressure. So it gets pretty deep, and most people don't realize that.
That's experience, though.
How crazy it gets with even just bolts and hardware and studs. You know? Yeah.
Right.
Yeah.
So they ran a couple of different tests with that too, torquing to a certain foot-pound first, and then going back, or letting it sit overnight and going back to it, and
a factory torque to yield bolt. So that mock-up cylinder head I built.
Yeah.
You take a heat gun to it. You heat up the head, right? Aluminum expands, metal expands and gets hot, right?
Right.
A factory torque to yield bolt, the clamp load doesn't change. It's in what's called yield. The clamp load doesn't change. But a stud, which is not in yield, you're just whatever torque down as a certain clamp load,
right?
Like ARP hardware. When you heat that cylinder head up, it starts expanding. It starts exerting, pressure, and that stud's holding it. Your clamp load now starts going up, which most people don't realize. So it's a lot. Like I said, it took me a week straight of playing with stuff and literally building out a procedure to how you prep the hardware, right? Like, not only do you pull out of the box and just assemble it.
Yeah.
The cleaning process, you have to prep the washers a certain way. We do preventative measures so washers don't slip. What lube you use, where you put it. The torque procedure, is it torque? Is it multiple steps? How you do it? How you hold the wrench? It's all comes into play.
Yeah, it makes sense because when I got the tour earlier too, I saw the engine room and Ty was saying that you guys have certain temperature in there and like everything is just like, it's almost like you should be wearing a suit in there.
Yeah, I mean, I kind of want to build it like a lab, right? Like
it's like a lab.
It's got its own HVAC system, and there's a sealed room, and that's our clean room, right? So everything sits in it runs over the weekend, because when I come in Monday, I'm not going to turn AC on. Now this block is 90 degrees.
Yeah.
You know,
right.
I want everything at the same temperature. So when you're doing your measurements of all the stuff, when you're measuring down to, to that fine a resolution, 20 degrees temperature in the metal changes it. So you can't measure something out here at 90 degrees, and then go measure the clearance somewhere at 70 degrees. You're going to get different results. You got to keep them equal.
Yeah. That's crazy.
Yeah.
It makes a lot of this stuff is making sense now as to why you guys have all these tools to play with in here.
Yeah. And our teardown area, which we call our dirty area.
Yeah, it's supposed to be dirty, right?
Yeah, we got our MagnaFlux machine there for testing for cracks and stuff like that. But I give tours. I'm like, this is our dirty teardown area, and they're like, this is cleaner than other shops I've seen where they put their motors together and
no, 100%.
Dirty. And I'll credit Lance. Lance is amazing, and he's meticulous. He's super process oriented, and him and I working together, developing that whole program, and him taking even further than I could imagine, and getting everything to basically perfection. Because again, if you're a carpenter building a house, it doesn't matter if that wall is half an inch higher over there than here. But if you're building an engine and one critical tolerance is out by, a few tenths, you're done. You're done. Everything's got to be perfect.
Yeah.
Yeah.
That's true.
Yeah.
That is true. Oh, all right. I haven't done this in a while, but some people wanted to have some questions for obviously Martin to answer. So first question is going to be, do you plan on pushing the C8 Z06 platform at all?
No, it's not something, we got to be, and that's something, we've done in the past where we've gone, I'd say we've tried too many things, right? Because if you pick one thing, it's a lot of effort that goes into getting something right, like developing the V10 platform or developing anything where you go kind of deep dive. The amount of effort from electronics, tuning, engine development parts is pretty massive, the amount of assets you need there. So, I'm guilty of it in the past of spreading ourselves too thin, and you're not good at anything, right? So I'd say with the resources we have now, that's not something, unfortunately, I think we get into, because it would dilute from everything else, right? And make so it's.
I think that question was probably more so because that platform is like, I think it's going to be pretty big once they figure out the transmission.
Yeah.
So it'd be cool to kind of see AMS involved in that. Yeah. I mean, obviously, you guys don't even bother with American cars, huh?
We do some Ford stuff.
Ford.
So we did the 13th gen F-150. Okay. We made in our testing, intake boxes didn't do anything for power. Well, we made turbo inlet tubes, which were from the air box down the turbos. We tested, measured pressure drop. Like, man, it's losing 2 psi of pressure there.
Right.
So we made those for that truck, and other people copied us with those. But that bought you 20 horsepower on top of what we could do before with that truck. But that's something we're looking at now, getting into some other stuff like that, which we're really good at. When we come out with a product, it's not just rehash. It's actually, hey, there's a benefit. It's going to be the best out there, and with what we've done with our business, our goal isn't to be out of reach. We want to be a good value, right? You're buying the best, but it's still a good value.
Right.
So that's so we're looking at other markets like that for sure.
Cool.
Yeah.
Somebody said, ask about the Silver Evo, which we kind of spoke about already. But I guess if there's anything else that comes to mind with that platform, we pretty much spoke about everything, I think, right?
Yeah, I mean, I think we covered a lot of it, but I think that was our first kind of deep dive platform where we went, really far in, like drag racing and chasing crazy horsepower numbers with, I think we really built our brand, when we did that car, right? Because it did so many crazy things. So, it'll always be special to me. We have an Evo, the turbo test car that we built for testing turbos, and like we talked about, selling it. I'm like, I want to keep it. I want to kind of return it back to stock, and I want to keep that because it does, it does have a special place. I'm not super nostalgic. I tend to not dwell in the past. I want to look forward, but that is it really put us on the map.
Out of all the platforms you've worked on, what's your favorite? That's my question.
Yeah,
Sorry, guys.
yeah. God, I don't know if I have one favorite. That's hard to say. I mean,
You only get one choice.
only one choice.
Only one.
Oh man.
You know, because these new cars, you can drive them to the store. You can go to the track, race them, go home with it. Like,
Yeah.
that's the benefit of having something like this. But like, I'm sure there's a lot of history with a lot of the cars you worked on. So I'm sure.
I mean, it's a toss up between GT-R and these cars. I mean, like the GT-R, because it's such raw power. It's very very different than the V10s. Like, these are very smooth. Like, it'll be very fast, but deceivingly fast. The GT-R is like a bull. I mean, it's so much torque.
Yeah.
The way it hits, you know, you got the engine up front. You don't have as much weight over the rear axle, so it tends to dance and move around a little more.
It's more of a raw car.
Yeah, it's more of a raw car.
Yeah.
Yeah, more of a raw feel.
Right.
Yeah, exactly.
So you wouldn't take an Evo?
Evo?
No DSM. You got a 1G back there.
Yeah. I mean, I love those cars, you know, and they have their place. But I'd say, as far as favorite, I'd have to say GT-R overall. Just the capability of it, the car it is. I mean, you know, I'd probably say GT-R. Yeah.
GT-R.
Yeah.
That makes sense. Somebody said, "Do you make parts for the VQ engines?"
We don't. No, we don't make the VQ.
You don't make parts for the VQ engines?
VQ?
Yeah.
No, just the VR. Just the VR30. Yeah.
How far are they trying to push the VR30 platform?
You know, our goal is to break the 1,000 wheel horsepower barrier. To go much beyond that, I'm not sure if it makes sense, right? Because, you know, we're still, I mean, people don't realize how many stock parts you're still working with. Yeah. We replaced a lot of parts, but it's still, if it's a fraction of everything else, the transmission is still technically mostly stock, right? So at some point you're gonna have trans issues. Now you got to go into a trans development program, and just I mean, for the average guy, you know, or girl, like like, hey, you want 1,500 horsepower in a VR30? Let's be realistic. The cost to do that is going to be for literally, you can count on one hand, right? So, you know, how much effort do we want to put into really chasing something that far? We're probably near the limit, right? We've got the fuel system now developed. We have the engine program. You know, it's going to be somewhere in the, you know, it's not going to be ton over 1,000 wheel horsepower, which is plenty for that car,
right?
You know, we got 940s in the Z with like 800. I mean, we'll probably go. The goal, I think, will be go eights with the Z or the Q with the engine program.
Still
now.
impressive.
Yeah. For that, I mean,
yeah.
Anything beyond that, you're getting out of touch with the you know, customer.
Well, that pretty much answered the next question, because it says, will the VR30 platform be anywhere close to the VR38 platform?
No, I mean, no, but I think 8s are realistic, right?
Yeah.
I think 8s are attainable, but just, I mean, the sheer architecture of the engine and the drivetrain, it's just not. You can't make something it's not, you know? It's
right.
Just, yeah.
Right.
Yeah.
So how much power do Huracan turbo kit and conversion usually cost, and are they reliable for daily?
That's a terrible question to ask me, probably price-wise. I don't know. I mean, you know, it depends what level, right? And that's kind of the whole thing. We have packages ranging from, you know, we call them our alpha packages, and the number represents the horsepower roughly. So alpha 9, 10, 12. We've got a 16, 20, 22, 24. So, you know, 9, like that. And those numbers are usually, we make more than that. So alpha 9 makes more than 900 real horsepower.
Right.
Alpha, you know, 16 makes more than 1,600 real horsepower. That's like almost guaranteed, like that'll make that. But the price varies. I mean, you can get on the low end, I think Alpha 9 installed, you're talking probably, don't quote me on this. Again, I'm the right person to ask, but probably the $45,000, $50,000 range, you know. But you got a 900 real horsepower car that drives like stock. I mean, it really does. I mean, we've got our R8 is still on a stock engine. Okay, when I say stock, I mean stock everything. Yeah, stock heads, stock rods, pistons, never opened up, and we've pushed that thing to about 1,800 wheel horsepower. It went sevens. I think went sevens 7 times on a stock engine. So these engines are really strong. The transmission is what needs help. But I mean, if you're in the Alpha 9, 12, those are super reliable on a stock engine. They're almost a no-brainer. They drive great. They're very reliable. Even though I say when we get into the Alpha 16, those are fantastic street cars. Once you start getting into Alpha 20 and plus, I mean, again, you're at the limitation of a lot of stock components. So there is more risk there. I mean, we've got a customer who's got I think he's a third fastest V10 car at 840s, and he put 10,000 miles on that car.
What?
Yeah, he drives like to the city, but with a coffee in the cup holder and everything. He drives the city.
That's the beauty of it. Yeah,
and it runs it's run 840s. So
he could just punch it at any time and just go.
Yeah. So, but yeah,
that's crazy. So the next question is, how should a Cadillac be souped up? A
Cadillac?
Yeah.
Oh, I don't know crap about. I mean, I don't know. I don't know anything about Cadillacs. I do have some pretty cool. Turbocharged options out there now. The AT something 5, 6 S Blackbird. I don't know, Blackbird, something like that. I really don't know much about them, but I
random question.
Yeah, I couldn't tell.
I didn't ask where AMS came from, the name itself.
Man, so I've always loved cars, and my dad used to go to. This is back in '80s. He used to go to Germany with his friends. He's also a mechanical engineer, but as a side gig, they'd go to Germany, buy cars over there. This is when the U.S. dollar was really strong compared to the Deutschmark back then. They'd buy like Porsches, Mercedes that were like a year old.
Yeah.
Import them here, convert them to be legal, and make money on them selling them here. But he'd bring back car magazines from Europe.
Right.
And one that was a German car magazine. It was like Automotorsport or something like that. That was a car magazine, right? And I remember that was my first kind of insight into the car world, and that's kind of where this Automotorsport is the name. But then that was a mouthful. People call it Automotorsport, and then people call it Automotive Sports. Are you motorcycle? So like AMS. Let's just shorten it to AMS.
Yeah.
So that's where the name came from.
And then the Alpha, like, how did you introduce that into kind of like brand?
So that came with the GT-R, because we're thinking like, okay, GT-R, it's like, it's a supercar, right?
Right.
I mean, Evo's I consider a sports car, right? And man, I wish they'd make the Evo again. I really I wish manufacturers would go back to, affordable stick shift sports cars. They don't have to make 800 horsepower. They could be, 400 horsepower, like the Z, like something like that. If more manufacturers brought that back, I'd really love that. We're seeing that kind of die down, unfortunately, but
thanks to BMW.
Yeah. Yeah. But what was I talking about? Where did I get sidetracked a lot?
You were talking about the Evo, and you wish that they had made more manual cars.
Oh yeah. I wish it'd make more of those cars. Bring it back, but I don't know if it's manufacturers not want to take the risk, is a consumer is not wanting that. I don't know.
So is the
Alpha logo? That's right.
Alpha. That's what I was.
Oh yeah. So when we got the GT-R, like that's a supercar, right?
Right.
So it's like a kind of like in the car category, you got sports car, then you have supercar, right? So we're like, let's make a product line that kind of reflects that, right? AMS is kind of our brand. Let's make Alpha kind of the supercar product line. So that's kind of it was same along the line as Nissan Infiniti, right? Toyota Lexus.
Yeah. Let's
make a separate brand that's more kind of a higher end or higher line brand. That's where we kind of came with the Alpha brand. So we kind of now we use them interchangeably, but we kind of try to like, okay, certain cars can be AMS product lines, certain cars can be called Alpha line.
Right.
Same amount of quality and engineering goes into each one.
Okay,
we're not taking any shortcuts on an AMS product line by any means.
So is that logo Sony inspired at all?
Sony?
Yeah.
I don't know.
Looks like the Alpha.
Oh, the Sony. Yeah. No, I mean we've had this logo since the GT-R, so 09, I think 09.
Damn,
so I don't know.
Sony got to cut the check.
Sony got
AMS.
Because I saw the cameras. I saw
for me, obviously I was like, wow, that looks familiar. I was like, oh, it's not the same. It's a little bit different, but I just thought that was pretty funny.
Yeah, it's just a variation of the Greek letter. I mean,
Sony cut the check. No,
but I think that same background, they have like a red, right? Like red background.
I think it's different. It's like I think it's orange or something.
Really?
Like that.
Oh, okay.
Actually, it's right there. Yeah. pretty cool. But yeah, I think that was pretty much it there.
Yeah, but I appreciate you coming out and let me share the story here, some of the ups downs of being a business owner of this industry, and all I can say is, I hope it keeps going. Obviously, we have the threat of EVs out there, which kind of subsided a little bit, and but in the long run, it's still a threat. So I just hope this industry, we can keep it going.
EVs?
No, it's the performance industry, right?
Okay.
The EVs being the threat to that,
Yeah. Sorry, I pulled up in a Tesla today, so.
Yeah, no, and they have their place, I mean, commuting, stuff like that. But I really hope there's still car enthusiasts out there down the road, and people still want to tinker and make more power with their car.
It's going to be tough, man.
It's going to be tough. It's a challenge.
But I do appreciate you so much for taking the interview as well.
Yeah.
And you've done a podcast before. Yeah. But I think it's cool that you were able to get on the podcast because it's pretty much what's trending now.
Yeah.
So it's pretty cool to have you on, especially with your history and how many accomplishments you've had over the years in the car community. So I thank you, and I hope to see more from a lot of these other platforms, and especially the Lambo. Yeah. More importantly, because that's the next time you're going to be out with this car, right? Is one of the more recent events coming up? Yeah,
Lambo. I move a lot of other cars. I mean, BMW stuff we're getting into now too. So a lot of exciting stuff.
Yeah. So what's the next event with this? Is World Cup? Are you going to World Cup?
I think MIR World Cup. Yeah.
You guys don't do FL2K, do you?
Depends. Sometimes we do, but it depends on timing of events because sometimes they're so close. Of
prepping
a car for one and the other is a lot of work. So yeah.
Well. Best of luck. Thank you so much, Martin. Appreciate it. For those of you guys who are listening, watching, make sure you guys keep listening and watching on all streaming platforms. And yeah, make sure to like, share, comment, and subscribe. And we will catch you on the next one. Peace.